Hey guys, so today we're going to be talking about complementary angles and how it relates to trig functions. So just to remind you what a complementary angle is, kind of show you in some of these pictures here, a complementary angle to another, they basically add up to 90 degrees. So if you have 60 degrees, okay, as your angle, then the complement to that angle would be 30 degrees because 60 plus 30 equals 90. Okay? And it shows you again here, you have a right triangle here. If you have a right triangle, now it has to be a right triangle when you're dealing with these, but if you have a right triangle, and this shows that it's 90 degrees, then your two other angles should also add up to 90 degrees. They should be complementary to each other. And the reason is 90 degrees plus 90 degrees is 180, and we know that there are 180 degrees in a triangle. So again, if you have a right triangle that you're dealing with when you work with these trig functions, which you should, then the other angles in the triangle, they should add up to 90 degrees. So that'll help you when we do this. And then there's also this also we'll talk about sine of x equals cosine of the complement of x. The complement can be written as 90 degrees minus x. Okay? And then the cosine, same rule, the cosine is equal to the sine of the complement of x. Okay? So we'll talk about that. So the first problem on here that you have to know how to do, so for example, sine, if sine is 30 degrees is 1/2, then the cosine of what angle will be 1/2? So what I did is I drew an example of this. Okay, so we have 30 degrees here. This is an angle that we're working with. Okay, and it said the sine of 30 degrees was 1/2, 1/2. Remember sine, I don't know if you guys remember doing this, but SOHCAHTOA is a good way to remember just how to set up sine, cosine, and tangent. The sine, if you're going to make a ratio with the sine, is opposite over hypotenuse. So if I look at the angle 30 degrees and I go to the opposite side, I get a 1. Okay, and you can see that's what's on the top. So 1 over the hypotenuse is the longest side of the triangle, and that's 2. So again, the sine is opposite over hypotenuse, so 1/2. So that's why I set it up like that. So the sine of 30 degrees is 1/2. Okay, so it's saying the cosine of what angle will be 1/2? Well, we can do this by looking here. We can also do it by using the properties we had before. So if I were to put the sine of x equals the cosine of 90 minus x, that was on the previous page, okay? So if I say the sine of 30 degrees equals the cosine of 90 minus 30 degrees, 90 minus 30 is 60. So that's saying that the sine of 30, which is 1/2, will equal the cosine of 60 degrees, which will also be 1/2. So that means that this up here should be equal to 60 degrees. And we can kind of see that in the picture because we have a 90-degree angle here, and then we have a 30-degree angle here. So we know then if these both are supposed to add to 90, remember these two are complementary, so that means that 30 plus what gives you 90? Well, 60 degrees. So 30 plus 60 gives me 90. And so now if I look at that, the cosine then of 60, let's check and make sure it's 1/2. The cosine of 60 is, remember, adjacent over hypotenuse. Cosine is equal to adjacent over hypotenuse. So The adjacent side that's not the hypotenuse is 1. So if we look at, again, starting at this angle, if we look at the adjacent side to that, that's 1, and the hypotenuse is 2. So that's 1 over 2. And indeed, that's what we've got. So that, again, that's using this property here, and you can draw a picture of it as well. Okay, so now you should be able to do the other problems on the worksheet. So I hope that that explains how the sine and the cosine are related for any angle that you give.